maxes and mins. A little more realistic. I don't know if you guys have a ranch, but you want one?
Yeah. Ranch dressing?
No,
Oh.
a ranch. Like you want to be a rancher?
Like with carrots?
No, like with animals. Okay, so today on this one I give you the drawings, a couple of them, to kind of help you visualize what's going on, but on the actual test, there wouldn't be drawings. So tomorrow we'll practice without drawings, but I just like start you with, we'll take away. So, how is that a bad drawing? It's a freaking rectangle. How would you make it better? Now?
Wait. Let's connect the lines.
Well, that's supposed to be a ranch, right?
It's supposed to. Oh my God.
Wait.
Or the animals.
Wait.
All
What's
right,
your
so
favorite
you want more detail.
Well, yeah.
Gotcha.
Yeah, what's your favorite movie? What's the test? Like, what's the test for that now?
We started the unit yesterday.
I know.
I don't know.
Wait.
Can I start teaching the class now?
You're telling me.
Okay. So there's going to be a function that we are looking to maximize or minimize. And usually there's going to be something that you know that you're like working around. So like in this case, I know I have 200 meters of fencing. What I'm trying to do is enclose the largest possible area. So this is like a real life situation. Like fencing costs money, you got 200 meters of it, I don't want to buy more, but I want to enclose like as much land as I possibly can. And I want two rectangles that are sharing one side, so they're adjacent to each other. So you're going to label the sides. You can do it a couple different ways. I think I would probably call this X, which makes this X, this X or Y, whatever. And then I would think I would call, you could call this whole thing Y. And each one of these is half. Let's do that. That whole thing is Y. That whole thing is Y. We could have also called like this part Y, this part Y. Depends how you set it up, and then we'll like, adjust to it at the end. So I've got 200 meters of fencing. So what equation do I know right now is true? You write an equation that is a fact. 3x plus 2y equals 2y. So that's just adding up. I've got 3 x's, I've got 2 y's, I've got 200 meters of fencing. And I'm trying to maximize the total area of all this. So what is the area of all of this? X times y, y times x. So x times y, and right now we're just going to say x times y equals max. I don't know what it is, but that's what I'm trying to find, is the maximum value for that. So, I can't take the derivative, well, I could, but it's a whole different ballgame, it's not necessary. I want there to be one variable here. And then, what level do I get to find maxes or mins? First derivative. So once I have one variable here, I'm going to take the derivative of it, so it equals 0, and work from there to find out what the max is. But I need one variable here first. So I need to solve this. This is kind of like your secondary equation that you're using to turn the primary equation into a one variable situation. So I would solve this for one of the variables. It doesn't really matter which one. Let's say I solve this for y. So it would be y equals, so it'd be 100 minus 3 halves x, right? So if I subtract the 3x from both sides, and then divide both sides by 2, you get y equals 100 minus 3 halves x. You with me there? So now plug this in, and I'll get x times 100 minus 3 halves x equals max. And that's the equation I'm trying to maximize. I want to know what's the x value that makes that equation the biggest. So I got to take the derivative of it. It's a lot easier for me to take the derivative if I don't have to use product rule, right? Like I could do it there. I think it's a lot easier if I distribute. So that's okay, 100x minus 3x x squared equals max. And the hard part's done. So I mean, I'm gonna keep going for sure and show you. But other questions, I just want to stop. But are there any questions on where'd you get this from? Why'd you do this? What's going on here? Yeah, at least. Okay. So let's take the derivative and solve here. So the derivative of 100x is 100. Derivative of 3 halves x squared would be 3/4 minus 3x. And I don't know what the maximum value is, but it's a number. What's the derivative of any number? 0. So then if I solve this, I get that x equals 100 over 3. Like 33 and 1/3. 100 over 3, it doesn't matter, whichever way. And then we gotta make sure we're answering the question. So like I'm solved for something. I feel like I've accomplished something. But the question can be phrased a lot of different ways. So they could say, what is the largest area we could enclose? They could say, what are the dimensions to enclose the largest area? They can phrase it kind of different ways. So in this one, they're saying, what dimensions should the rancher use? So what they're asking for is like, what's your x by y? So my x is 33 and 1/3. By, how do I find my y? I got my like secondary equation, I call it up there, right? So I know that y is 100 minus 3 halves times x, or you could plug into this one, whichever way you want. And you're going to plug into one of those, plug x into one of those, and find out what y is. So I'm going to use this one actually. Because 3 times 100 thirds will just cancel. So that's 100 plus 2y equals 200. 2y equals 100. So y equals 50. So the dimensions that they're looking for are 33 and 1/3 by 50. But sometimes it'll say find the largest possible area that can be enclosed. And then what would you do? You just multiply those together, right? But it's super annoying when you do all the calculus right and then you forget to like read the question correctly and you answer the wrong thing, you know? So just be careful what you're reading. Questions on that one I can go through? How does that seem? Solid. Alright. Let me give you a minute or two to try to set up number 2. See how you do. I gotta do a hard project. What, Caleb? You know what me doing it. That does sound fun. I'm sorry that you were disappointed by the range. whichever side X, whichever side Y you want. You don't need this side, right? This is where the drawing's really helpful. So keep in mind you would have to be able to do this without a drawing given to you. I think I'd probably call this one X and this one Y. I don't know how many did it the way I did it with X and Y. How many flipped the variables? It doesn't matter. It's just like you gotta follow. You can still follow it. So what we know, we have 500 feet of fencing. So in mine, it's 2x plus y equals 500. You might have done 2y plus x equals 500. It's the same idea. And I want the largest possible area. So I want x times y to equal max. And then I want to take the derivative of this. But the problem right now is it's got two variables in it. So I want to get it down to one variable, which I'm going to do by looking at that equation. So I think it's easiest just to say y is equal to 500 minus 2x. You got a choice. Like you could solve this top equation for x or for y. But it's just like a step easier to do it for y. And then plug this in. X times 500 minus 2x equals max. And that's like your setup. So let me stop there. Questions about what I did? Why I did it? Gucci? People still say that?
Yeah.
Everybody. So I'm going to take the derivative. So I could use product rule, but I think it's a lot easier if I distribute. Before I take the derivative, so that should be distributing, so this stuff's max. So I didn't take the derivative yet. So now I'll take the derivative, so 500 minus 4x, and again, I don't know what the max is, but it's an area, it's a number. So the derivative of any number is 0. And if I solve that, I get 4x equals 500, so x equals 125. So I know this is 125. And then you don't even necessarily need to plug back into the equation. I mean, you kind of do it in your head. If you have 500 feet of fencing and you used 125 twice, you've used 250, so how much is left? It's 250. You can plug it back in here. It's the same exact thing. So if I solve that, I will get 250. And then I can ask two things. I can say, what's the largest area? Multiply 250 by 125 and see whatever that is. This one says, what dimension should we use? So you're just going to say it should be 125 by 250. Question on that one? We're at? Yes. I thought I made an art project. Read through number 3. Yeah. Because like this is 250 by 250, you split it.
Yeah, like I did the calculator.
So I worked with this one too, so this will be
I misread this.
100 by 100. But 100 needs to be split into half. And it's,
Yeah, so I thought.
that's kind of cool. Yeah, yeah. It makes sense. I guess. That's cool. Yeah. Okay. Make sure you check the calculus. Like I think that probably works every time, but just to be sure. Okay. So I got a poster, and then I cut out x by x squared with each of the 4 corners. This is x, this is x. And then I fold up sides. That's doing a box, right? So the question is, how big should those squares be to make this box have like this big a body? yeah, then it's not very good teaching. Yes, it is. Wait, no, it's not. I'm doing the wrong question. Oh, yeah, yeah, yeah. Did I even put this one on here?
Sorry, you made
Dang it! That was so cool. I got so excited. Well, we're gonna do this one tomorrow. So keep this in mind. Okay, hold on.
Nice.
Okay, so if I call, let's say I call this X, that Y. I think makes sense, right? Because X goes like horizontally and vertical, Y axis. What dimension should the poster designer use to choose to use the least amount of paper? So, wow. Graphic designer cares. So, I'm trying to use the least amount of paper. So, what am I trying? Am I trying to maximize or minimize? Minimize. And what am I trying to minimize? What's another word for like inside an amount of paper, like a map word? Area. I'm trying to minimize the area, right? So what's the formula for the area of that rectangle? We want x times y to equal min. Fair enough?
Fair enough. Hard.
What is a 162?
Photo is 162.
Centimeters squared.
Hold on. Oh yeah, so x times y is 162. My bad, thank you, man. Yeah, so then if I have to look at the dimensions for the overall thing, if this is, so this is 162 in here. If this is x, how big is that? X plus 4, right? Because this is x, and you're adding 2 on this side, and you're adding 2 on this side. So this is x plus 4. And this one?
Y plus 8.
Y plus 8. Because you got the y here, and then 4 here, and 4 here. And that area is what I want to minimize. So what's the area of this by this? Is just multiply those two things together, right? So x plus 4 times y plus 8 is what I'm trying to minimize. So I want to take the derivative of this and set it equal to 0 and do my process, but I'm stuck because there's two variables. So what do? Solve that top one for one of the variables. It doesn't really matter which. Let's just divide both sides by y, let's say. So x equals 162 over y. And then if I plug that in, 162 over y plus 4 times y plus 8 equals min. I'm debating whether to make it y to the negative first or not. You guys think it's easier like that or with y to the negative first? Like 162 y to the negative first? Like this? Okay. Alright, so let's FOIL it. So 162 over y times y. What's that? 162. 162 over y times 8 is something big times over y, right?
Right.
I'm just gonna got this. I think that's right. 1296 over y. 4 times y is 4y. 4 times 8 is 32. And is this equal to min or equal to 0? Min, because I didn't take the derivative yet, right? So now I'm going to put it as y to the negative first, because I got to take the derivative. So, can you give me a second? I'm getting there. So this is 1296 y to the negative first, right? I'll bring this up, which I'm doing because I'm going to have to take the derivative of plus 4y, and then it's actually plus 194, right? Those two you can add together. And is this equal min or 0? Min. Finally, yeah. They're gonna go away in the end anyways, but I still like to get it right on the way. Yeah, but this number, when I take the derivative, what's gonna happen to it? It's just gonna go away. Okay, so take the derivative. So negative 1296 y to the negative second plus 4 equals 0. Now we did this. You guys took the gateway. We gotta get this into one fraction. It's at the top and bottom equal to 0. So we have to make this into one fraction. So this is 1296 over y squared plus 4. So then what do I need to put on the bottom here? Y squared. So what do I need to put on the top here? Y squared. So now I have negative 1296 plus 4y squared over y squared. My job is to set the top and bottom of that equal to 0. The bottom is just going to give me y equals 0, in which case I'm not adding, I'd have a 0 by 0 rectangle. That doesn't make any sense, so I can kind of disregard that one. Y equals 0 just doesn't make any sense given our problem. And I'm going to solve the negative 1296 plus 4y squared equals 0. So 4y squared equals 1296. If I divide that by 4, I get 324. Alright. Yeah. Then what? Square root it, and if I square root it, I get plus or minus 18, so it's important to always remember the negative, but can the rectangle be negative 18 by something? That doesn't really matter in this case. So y equals 18. So we still don't answer the question. Questions on what I've done so far? Okay, so the question is, what overall dimensions of the poster should I choose? And the poster, remember, was x by y equals 162. So x times 18 equals 162. Right, to find out what x is? If I divide both sides by 18, I get 9. So the dimensions that I should choose are 18 by 9. Yeah. What overall dimensions for the poster? You are right. I'm not done. This is the dimensions of the photo, right? I keep mixing up photo and poster. So yeah, right. So if the photo is 18 by 9, thank you. So this is 18. But what's the actual length of the photo going to be? Poster. Why do I? 26. Does that make sense? I know I can't say words, but do you see what's happening? This right here is 18. But they're asking for this. So you gotta add the 4 and the 4. So it's 26. And then what's this one across? 13. 26 by 13. So that's the answer. Thank you, Brad. That's a battle. Posters are stupid words anyway. Is that alright? Questions on it? read through number 4 and try to set up an equation. It's pretty tough, I think, the first time you see it. But profit, I mean, just helpful. Profit is income minus expenses, right? See if you can tell me what the income is, and what the expenses are. You're trying to maximize profit. This is like if you take calc-based economics in college, you're trying to maximize profit like over and over and over again. That's like the goal of a company, right? How do you find max? You take derivative. That's tough. If you just want to wait till I do it, it's fine. But I want to give people a chance. That was your best running shoes. You should try transfer.
I do do it. You do.
Trench running.
Trench running should be the best motion championship.
Really? Which makes sense when you play tennis.
Well, I would play tennis and science, but
Okay. So income, profit, income. If these weren't X's, this would make a lot more sense. So let's like put them in terms of, let's say they're not X's. We sell a new smartphone at the price of $80, and X is the number of smartphones manufactured per day. So one weird thing about this question is we're assuming that every single phone we manufacture, we also sell. Not the case in the real world. We're saying that we are. So if they're $80 and I made 10, how much money did I just make? And I sold them all. 800. So what do you do with those two things? Multiply them together, right? So this is the price that we're selling the smartphone for. This is how many we sold. So our income is just multiplying those two things together. Which again, this problem assumes that you're selling every single one that you make, which is not a real world scenario, but I'm just trying to simplify it down. Our expenses. What?
Why is it 100 minus 1x times that?
This is the price of the smartphone. So the price depends on like how many they make, like a supply and demand type thing. And then this is how many we sold. So it's just the price times how many we sold. I get that it's a little weird. It's like an X and an X. Does that help? Okay. And then your expenses. Well, the parts for each smartphone cost $40. And how many smartphones are we making? X. So that's 40x. Plus, we also have to pay $4,000 to run the plant. But does that depend on the amount of smartphones? It doesn't. So that's not 4,000x. That's just 4,000 with a fixed cost, which does not impact how many we're supposed to make, because eventually we're going to take the derivative of that, and what's going to happen to it?
Why?
It's going to go away. Yeah. So the whole question is like per day. So we're only looking at 1 day. So it just kind of like takes care of itself. So that's my like profit equation. And then my job is to try to maximize. By far the hardest part is setting it up. Question on what I did to do that. So go ahead and try to finish it. Tell me how many smartphones we should make. I don't know what the drawing space is for.
Yeah.
Maybe you're supposed to draw a phone. I don't know. I mean, it's just got a bunch of apps on it. This is Spotify. That's my camera. This is my mail. I don't know what Waze is. Can you do the problem? Maps. You guys probably don't have this one, but this is Target. You know what Tesla? No. This is Explorer. It's not really an app. This is Google Drive. Oh yeah, Google Chrome.
That doesn't make sense.
Schoology. I know you guys all have Schoology, right? Oh, the phone. Google Home. Why are you done? What's wrong? You just are. That is the original equation, the one that we are trying to maximize. So, our job is to take the derivative of that, so that equals 0. We don't have to worry about a second equation in this one, because there's only one variable. So you take the derivative of that, so that equals 0. I would distribute first, then take the derivative, so that equals 0, and solve for x. Does that help? I'm sorry, you're like struggling with the question. I'm just drawing Google Home on my paper. Yeah. 70 divided by 1/5 is the same as 70 times 5. ADT. Wait, that was Spotify.
I got x equals -3. You already drew Spotify.
I know, I drew over it. So Ethan, you're saying we should make negative 350 smartphones?
Yeah.
This is the Play Store. I'm an Android man. Dividing by 10 halves, yeah. Yeah. You said that really confidently too. Like, kind of sounded like a smartass. Okay. Basically, so I would distribute first, and then like distribute the negative side through, and that still equals max, right? I didn't take the derivative yet. So then if I combine the like terms, I'll get this. That still equals max, and then take the derivative. So negative 0.2x plus 70, and then this goes away. Which, if you think about it, it makes sense that if I'm trying to maximize how many smartphones I should make, it doesn't matter how much I paid up front, because that's just gone. Like, I'm working from that. It matters whether I'm going to make money or not, but it doesn't matter as far as like how many I should produce. So yeah, it matters if you're going to make it. But so then I get this, and so dividing by 0.2 is the same as multiplying by 5. It's negative, so it'd be x equals 350, and that is how many smartphones they should make to maximize profit. Questions on that one? 2 is 1/5. So flip it. Questions on 4? Yeah, do they make a profit? Really? Per day? That's not bad. Give 5 a shot on your own.
Oh, crypto. Crypto. Is it Bitcoin?
No, it's crypto.
Bitcoin's at like negative 600 million.
Something around there, yeah. Yeah, I have to give them my car back.
Oh, no. How much money you lost?
Actually, up. $4.
Good girl. Aren't you up flying?
Yeah.
You put some money in the regular stock market?
Yeah.
Like a just like the index fund or a specific company or what?
Ford,
Okay.
Tesla, no, it's Delta, Amazon, Netflix.
Yeah, you can.
It's cool. They're all the way down right now, so hopefully it's good time to buy.
Well, because look at Netflix. It's like 1 week.
I know it went like way down. Like 50%, right?
Because they announced they're increasing their prices again. So
Are they really?
It went from like 500 to like 300. So I bought 300 because it's like
It's gonna go back, yeah. I would think. This is not financial advice. Mr. Davis told me to put all my life savings into Netflix.
No, you have to buy.
What? Yeah, they're pretty sweet, aren't they? They're toes.
Buy GameStop. Buy GME.
No.
GME.
Do number 5.
Dogecoin to the
Number 5 to the moon. Sorry, does that make you uncomfortable? I'll put my feet away.
Alright, I got it.
Don't ruin it. Did you check it? Answers are out there. You can check it. Give you the starting equation? That's like the hard part though, so I want to give people more time to think before I just give it to them. What time did that say? 54?
That's 54.
Okay, so I'm trying to minimize the product. You didn't get it? Of a positive and a negative number. So I'm just going to call like x is the positive number, y is the negative. And my job is to minimize the product. So I want x, y to equal min, as well as I can possibly make it. And then I know the positive number is exactly 5 greater, but I can't take the derivative of that yet, right? Because there's 2 variables. So I need more information. I need another equation. I know the positive number is 5 greater than the negative number. So doesn't that mean x equals y plus 5? It helps if you like actually put numbers in. Like 15 is 10 plus 5. But it's easy to screw that direction up. But yeah, so x is going to be 5 more than y. And then I can put y plus 5 in place of x. So I'm taking this and putting it here. You guys with me? So that's the hard part. So if there are questions there, please stop me. It told me to minimize the product. And it told me that the positive is 5 bigger than the negative. So then I would distribute, so y squared plus 5y, and that's still equal to min. And then take the derivative. 2y plus 5. So again, I don't know what the minimum is, but I know it's the number. The derivative of that number is 0. So if I solve that, I will get y equals negative 2.5. Which like makes me feel like I'm on the right track because that's a negative number. I said it was going to be a negative number, so that's good. And then I know x is y plus 5. So that's positive 2.5. And then again, read through the, yeah, stop. What? same thing, I think. Yeah, so it's fine. Because all they're asking for at the end is what's the product. So we're just going to multiply our two numbers together, and you're going to multiply your two numbers together, we're going to get the same thing. So I get my two numbers are negative 2.5 and positive 2.5. Whichever one you call X and Y, it doesn't really matter. You're going to get those two numbers, and then what's the final product? So they want me to multiply those two together. So negative 2.5 times 2.5 is negative 6.25. Or negative 5 halves times 5 halves is negative 25 fourths. Questions on this one? So you got the same thing, right, brother? Yeah. How's that? That one seem? So tomorrow we'll do 6, and then I'll let you actually do some on your own when I'm just not doing them with
Let's
you.
go.
Does anybody know if